Hello dear students, today we are going to discuss about permanent magnets and electromagnets. Obviously, another name of this electromagnet is temporary magnet. So, we are actually discussing about temporary magnets and permanent magnets. We already discussed in the first section about natural magnets, isn't it? After that, we gone to the section Easton's discovery of the relationship between electricity and magnetism. So, in the last section, we studied that a solenoid will act as a bar magnet, isn't it? And inside the solenoid, there is a cylindrical box, a cylindrical object is placed. Maybe a cardboard or any substance of cylindrical shape is placed inside the solenoid, isn't it? It's a solenoid. When a wire is wounded on a cylindrical object or cardboard, that is itself a solenoid. So we understand that solenoid acts as a bar magnet. Then we thought of why can't we create a magnet using a magnet for permanent use using this solenoid, because it has all the properties of a bar magnet. It has polarities north and south direction. When it is freely suspended, it lies in the north-south direction. It can attract the other magnet and other magnetic substances also. It can attract iron pieces also. So it shows all the properties of a bar magnet. Then why can't we make a bar magnet using that? We thought of that. And hence we make two types of magnets using this solenoid. First of all, we place a soft piece of iron inside the solenoid. At first time we told that we are winding this wire on a cylindrical cardboard. Instead of that cylindrical cardboard, here we use a soft iron core. So we found that this soft iron core, when electricity passes through them, it acts as a magnet. In the second type, we instead of this soft iron core, we introduce hard piece of steel, or we introduce a alloy that consists of aluminium, nickel and cobalt alloy of iron. Or instead of this, we use a substance called nipamag, which consists of iron, nickel, aluminium and titanium. So it's an alloy. It consists of all these four things. Which of them? Iron, nickel, aluminium and titanium. Alnico, this alloy consists of aluminium, nickel and cobalt alloy of iron. Or we use steel. So in that case, we seen that even after we remove the current, this material shows the magnetic properties. It acts as a magnet itself. So that was a huge discovery. See, at first inside the solenoid we place a soft iron core and we find that it acts as a magnet whenever the current passes through the circuit. That we know. But when we use these things, steel, alnico or nipamag, we found that it doesn't lose its magnetism. Even if we remove this electricity also, even if we remove this potential difference also, it doesn't remove its magnetic properties. So we termed these two things as one as temporary magnet, one as permanent magnet. So these things are permanently changed into a magnet. So let us discuss about this electromagnet and permanent magnets. So why we create these electromagnets or permanent magnets? Because it's not easy to get natural magnet, isn't it? We have to dig from the earth or we have to find. That is limited in quantity. But if you want to create it in a commercial purpose, for a metro station, we have to create a lot of magnet particles. Does it available in the natural form? It is very difficult to take it in the natural form. So at that time we must go for artificial source of magnet. That's why we go for this section, electromagnet or permanent magnet. So first of all, let us discuss about electromagnets. Electromagnets are made by winding or making solenoid on a soft iron core. This electromagnet acts as a magnet whenever the current passes through it. And when we stop the passage of current, when we remove this key, it will not act as a magnet, it will act as it is. If it is iron, it will act as iron only, it will not act as a magnet. We can change the polarity. It have a south pole and north pole, isn't it? If the current is passing in the clockwise direction, it indicates the south pole. If the current is going in the anti-clockwise direction, it indicates the north pole of the magnet. We can change the polarity of this magnet. How? If we change the direction of current. If we change the direction of current instead of, so what happens? The direction of current will be in this direction, from positive to negative. Earlier it was from here to here. Positive terminal was given here. So if we exchange the ends of the battery source, what happens? The polarity also changes. North will come to here, south will go to here. So we can change the polarity of a electromagnet. And so first point to remember, polarity is not fixed. We can change polarity according to our wish. Can be demagnetized. How we can demagnetize? If we remove the source of electricity, it is demagnetized. It no more shows the magnetic properties. And the most important point to remember, the magnetism or magnitude of magnetic field can be increased by increasing the electricity passing through them. So we can increase the magnitude of magnetic field. We can increase the magnitude of magnetic field. So these are the most important points to remember in the case of temporary magnets or electromagnets. They are made by winding wires on soft iron core, and its polarity can be changed when we change the direction of current. It can be demagnetized when we remove the source of energy or source of electricity. We can increase or decrease the magnitude of magnetic field by increasing or decreasing the amount of current passing through the circuit. How we can increase or decrease? By using rheostat. We can increase or decrease the amount of current. Hence we can increase or decrease the magnitude of magnetic field using this temporary magnet. And most temporary magnets are made in the form of U. This magnet has one more name, that is horseshoe magnets. That is the shape of a horseshoe. Column, you may know that. So that's why it gets its name. And this type of shape provide maximum magnetic field in a limited space. Within a small space, it provides maximum amount of magnetic field. Hence, mostly permanent or temporary magnets, they are made in the U shape, horseshoe magnet shaped. Okay, that's all about the section temporary magnets or electromagnets. Now in the next class we will discuss about permanent magnets. Hope you understood the section. Thank you for watching. Have a nice day.